Alright, so what we have here is we're trying to find the instantaneous rate of change, or the instantaneous, or whichever version of that word you choose to use. So we're trying to find the instantaneous rate of change here. And with the average rate of change, it's a lot easier because we just pick 2 points and we go between them. So if I wanted to find the instantaneous rate of change at that point there, I'd first need to know a few things. What would I absolutely need to know? Yeah, I need to know, not the white border, but I need to know where this lies on my function. So I'm just going to call this x equals 2, right? So let's say I want to know the derivative. Oh, you don't know what that word means yet. I want to know the rate of change, or the rate of tangent, at that point there. I'm sure there's a ruler in this class. No, there it is. So I want to know the gradient of my tangent. And for those of us who are potentially a little bit rusty on what that means I want to know the gradient of this line here. Sweet. How many points do I need to find a gradient? 2. So I'm going to say, well, let's pick this point x, 2, and a point really, really close to that. Get me a point as close to 2 as possible. 2 point.
It'd just be like, really,
You've spoiled the punchline. You're supposed to say like 2.1, and I see you can go close. And then you come in with your answer. So what Dave is saying is, if x equals 2, x plus h is some number, would equal 2 point. You tell me when to stop, Dave.
Can't.
Yeah, exactly my point, right? You just keep going on and on and on. Insert a million zeros, correct?
Yep.
And the equation for that would be, what's the equation for a gradient? So m equals
X, y1
y2 minus y1 over x2 minus x1. Now, I'm just going to replace these 2 points because I'm so slack, I don't want to write that. Instead of writing that, I'm just going to write 2 plus h. Sweet, and h is some really small number. Sweet.
So it's a small number close to 2.
Yeah, well, it doesn't matter. This point here is saying I want a really, really small number close to 2, which just equals 2 plus h, which is a really small number. Are we good with that?
Yes.
Cool? We're not good with that?
Oh, yeah.
Okay, we are good with that. So what I can say is, well, m equals, I'm going to call this one y2 here. I'm going to call this one y1. So it's going to be x plus h squared minus x squared divided by, which one comes first?
The 2 plus h.
Minus 2.
Are you working out different ones? Are you working out the first x, is that the y2 one? And then is the h that other one?
Yeah, I've sort of gone 2 ways about this, but I want to show it this way.
So we're not doing the first one?
What do you mean the first one? Maybe just give it a second or two. That'll do. So, are we happy with that? Everything I've done so far? Anyone not happy with what I've done? Because that was our original function, x squared, that's the one that I drew. And this is just going to be f plus x. Sorry, fx plus h plus a little bit there. We're just going to change that. Can I expand this? What's that become? So m, what am I? M equals x squared plus. Very good. 2. What's that? M. There it is. 2x plus h squared. So that's that first bit minus x squared. So that was that first, the bracket there, expanded. That's just staying as x squared divided by, can I simplify the bottom?
Yes.
Do I need these brackets anymore?
No.
So what's that going to equal? We good? Can I do anything else?
Yes.
What else?
You get to cancel out the x squared,
I can cancel this and this out, correct?
and then you can simplify the h.
Now I can simplify it. Very good. So I've got m equals 2x h plus h squared divided by h. Am I allowed to represent that like this? Is that the same thing? Very good. Can I do anything else? What can I do?
Cancel out 2x.
I can cancel this h out here with this one. What else can I do?
Cancel h squared becomes h.
And now I'm left with my gradient. Not with that pen. My gradient equals 2x plus h. What was h?
Really small.
Some really small number, correct? So small, it's like, would I even consider it?
No.
So because it's so small, I can just get rid of it. I'll just put a line through it. I'll let that equal 0 because it's so close to 0 it doesn't matter. What am I left with? 2x. What was x? 2. Would that work if I changed x to be 3? So if I had 3 and 3 here, would that change anything? All that would change is when I sub my x in, it'll be 3 times 2, which is 6. Cool. So I actually don't need this 2 and 2 here. What could I replace that with? How do I represent a number that shows me any value? It could be any number. But what was this number? That was the x value of my function, correct? So how do I denote that? Do I denote it with a number or? Instead I should write not 2 but x. Will the x's still cancel out?
Yeah.
So it doesn't matter what point I use this for. Welcome to adulthood. This is called calculus. Your friends, if you want to call them those in general, will never see this. They'll never reach this rite of passage. Some people put their hands in bull ants' nest. Some people jump from big towers. In Western culture, we do calculus. So when you leave the room today, you're going to walk a bit higher, a bit broader than all your peers in general. They're going to have no idea why, but you'll know. Anyone do general only? Yeah, if you're in a general class, that's how you feel. That's alpha. All right. So this is called first principles. What this does is essentially combines our understanding of gradients and the fact that we can pick 2 points really close and represent those with pronumerals. Cancel them out until we're left with x's and things that we can cancel out. Sweet? Do I expect that you're all good with that now that I've taught you once and it's going to be all sweet?
No.
Probably not. The only other thing I need to show you is the limit notation. So this one comes up with the first principles. What do you think that means?
I can't see.
What do you think that means? Slide. It means the limit as h approaches 0. So h gets really close to 0, but it doesn't actually equal 0. Because if h equals 0, then it's just going to be x2 and 2, isn't it? So it needs to be like 2.0000000, we keep going with the zeros. At a 1, that's what that's implying. So it's the limit as h approaches 0. But does h equal 0? We can treat it as though it's 0 when it's by itself, but only in that last line. Cool? Anything with h in it, what's it going to equal at the end?
0.
Very good. Cool? We need to practice that part.
What's the root?
That is derivatives.